Lesson 8.4, Solving Systems by Elimination with Multiplication. Lesson 8.4, Solving Systems by Elimination with Multiplication. Solving a system by multiplication and adding. In some linear systems, neither variable can be eliminated by adding or subtracting the equations directly. In systems like these, you need to multiply one of the equations by a constant so that adding or subtracting the equation would eliminate one variable. The steps for this method are as follows. 1. Decide which variable to eliminate. 2. Multiply one equation by a constant so that adding or subtracting will eliminate that variable. 3. Solve the system using the elimination method.
All right, let's take a look at another example and really practice this notion of solving by elimination. Turns out we have to have sort of a keen eye to know what we're looking for here. So here's one. Negative x plus 4y equals 1, together with 5x plus 2y equals 17. All right, now I don't see any real kind of cosmic conspiracy here, although I do notice that I could sort of make a conspiracy happen by taking the first equation and multiplying it all through by 5. Let's just think in our minds for a second what would happen if we did that and why this is a good idea. Let me also remind you that there's lots of ways of solving these. There's not just one way. So if you see this and want to do something else, as long as you work through it carefully and correctly, you'll get the same answer. Don't worry about it. I'm just showing you a way that I see. Okay? So if I multiply through by 5, I multiply this by 5, this by 5, and this by 5, both sides by 5. Here I'm going to have a negative 5x. But then I could add it to the second equation, and that will drop out with the 5x here. So I'm seeing I'm going to get a cancellation. I'm going to eliminate the x's if I multiply through by 5. So I'm going to do that. So I'm going to take the first equation and multiply it through by 5. So here I'm going to see a negative 5x plus 20y equals, and I have to multiply this side by 5. A great classic mistake is just to write 1 there and to forget that you're multiplying both sides by 5. So that's it correctly. And now I report the second equation without touching it at all. And now what I'm just going to do is add them up. If I add these two equations up, what do I see? Well, I have negative 5x plus 5x. That's just 0. So you see I've eliminated the x. And I see 20y, and I've got 2 more y's. I'm adding them together, so I have 22y. And that equals, well, 5 plus 17. Well, you know what that is. That's 30. That's 22. Divide both sides by 22. And I see that y equals 1. Okay, now that I have y, I can figure out what x is by plugging back in. Which do you think I'm going to plug back into? The second one or the first one? I always plug back into the equation that seems a little bit simpler to me. These numbers look pretty big, so I'm just retreating to the first one. So here I go. Negative x plus 4 times 1, which is just 4, equals 1. And so therefore I see that negative x, if I now subtract 4 from both sides, is going to equal, if I subtract here, I get negative 3. And then if I multiply through by negative 1, I see x equals 3. And so x equals 3 is the x value. So x equals 3, y equals 1 is the solution. If you want to write it as an ordered pair, it's 3, 1. And you can again check the answer by taking 3 for x and 1 for y and plugging them back into both of these, ensuring that both of these are satisfied.
All right, now before we move on, let's review and make sure you have these steps down. Okay, remember now we got two equations, and we see that we can eliminate the 5 if we multiply the top equation by 5. All right, in order to do that, you set it up by using 5 by using the distributive property. So see how I got 5 on the outside, parentheses, and then all of this is on the inside. So now 5 times a negative x is a negative 5x. 5 times a positive 4y is a positive 20y. And then 5 times 1 is 5. So that's my new equation. I write the old equation on the bottom underneath as before, and I'm going to add going down. A negative 5x plus a positive 5x, that's going to equal to 0, so that's gone. 20y plus 2y is 22y. And then 5 plus 17 is 22. So now I'm going to solve for y, a one-step equation. 22 times y. What's the opposite of multiplication? Division. So I divide both sides by 22. 22 divided by 22 is 1. So that's really 1y right there. But we already know the rule. All we see is 1y. So 22 divided by 22 is 1. So y is equal to 1. Now I can use the top equation or the bottom equation to find out what the x value is going to be. He chose the top equation. So the top equation says negative x plus 4 times y is equal to 1. So now in place of y, I'm going to put that 1. So now I got negative x plus 4 times 1 is equal to 1. Bring my negative x down. 4 times 1 is 4, and that's equal to 1. I want to get this x by itself, so I got to get rid of this positive 4. To do that, I subtract 4 from both sides. 4 here and 4 there. A positive 4, when combined with a negative 4, that goes to 0. It's gone. So I'm left with just a negative x. All right, this is negative x there. And then 1 minus 4 is equal to a negative 3. All right, now we want to make this negative x a positive x. So therefore we multiply both sides by a negative 1 here and a negative 1 there. All right, a negative 1 times a negative 1 is a positive 1, so it becomes a positive x. Don't forget that says a negative 1x. So a negative 1 times a negative 1 is a positive 1. And then a negative 1 times a negative 3 is a positive 3. So x is equal to 3 and y is equal to 1. Okay, this last step right here may be confusing the sum, so I'm going to rewrite it over here. So I'm starting from right here. Negative x plus 4 is equal to 1. Negative x plus 4 is equal to 1. All right, to get that negative x by itself, we're going to get rid of the 4. That's a positive 4, so we're going to say negative 4 and negative 4. Once again, this is going to cancel out. I'm left with just a negative x, and then 1 minus 4 is a negative 3. Now the way I would do this is as so. This says a negative 1x is equal to a negative 3. So I'm multiplying by a negative 1. So what I would do is I would divide by a negative 1. But you can multiply if you want to do it that way, that's fine. But a negative 1 divided by a negative 1 is a positive 1. So I'm left with just a positive x. And then a negative 3 divided by a negative 1 is a positive 3. And I'm left with a positive 3.
I know you want more, but I'm only giving you one more. Now this is going to be a little bit more tricky. Let's see if we can figure this out. I'm looking at a system that's 5x plus 6y equals 2, together with 9x plus 4y equals 24. All right, now it's not so clear how to make an elimination happen here, right? How are we going to actually have an elimination? Well, I got to think about maybe some number to multiply the first equation by, and some other number maybe to multiply the second equation by something. Maybe I got to multiply both equations by something in order to have an elimination. Well, if you think about it, if I multiplied the 6 by a 2, that would make it 12. And if I multiplied this 4 by a negative 3, that would make it negative 12. So I can get a 12y here and a negative 12y here, and I can eliminate the y's. Now again, you might look at this differently and see how to eliminate x's, and that's okay. But the way I'm looking at it is I'm going to multiply the top equation by 2. I'm going to multiply the bottom equation by negative 3. So both equations are going to be sort of fiddled with, but they're just going to be generated into equivalent equations. I'm not changing the system. I'm just writing it in a slightly equivalent way. So first, let's just take that top equation, multiply it all by 2. When I do that, what do I see? Both sides. 10x plus 12y equals 2, 2, 2, 2, no. I've got to multiply everything through by 2, so 2 times 2 is 4. Now, I'm also going to manipulate the second equation. I'm going to multiply it through by negative 3. When I do that, what do I see? Well, negative 3 times 9x is going to be negative 27x. And then I'm going to have a minus 12y equals, and then negative 3 times 24 is negative 72. All right, now, was this a good idea? Let's see. What I'm going to do now is add these two equations together. And notice that here I see a 12y plus negative 12y. They cancel out. They're eliminated. So this actually seems like a good idea. Here I've got 10x plus negative 27x. So the net gain is what? Well, negative 17x. And what does that equal? This drops out, and this equals negative 68. Okay, so now I divide both sides by negative 17. And I see that x equals, well, negative 17. A negative divided by a negative is a positive, and 68 divided by 17 turns out to be 4. So I see x equals 4. How do I find out what y is? Well, I plug back into either of these. Which one would you pick? Doesn't really matter. I guess I'll pick the top one. It seems a little bit smaller. So I'm going to put 4 for x into the top one. So I see 5 times 4 plus 6y equals 2. So that's going to be 20. And so what I see here is, continue on a different page so we can all look at this together. I see 20 plus 6y equals 2. I'm going to subtract 20 from both sides. And when I do that, these drop out. I'm left with 6y equals negative 18. And if I divide both sides by 6, I see that y equals negative 3. So y equals negative 3. I see that x actually equals 4. We've already found that. And so the big finish is that my answer is x equals 4, y equals negative 3. Or if you want to write it as an ordered pair, 4 comma negative 3. And again, you can check your answer by just taking these values, x and y, and plugging them back into both and showing that both are.
All right, now remember on this particular problem right here, we are eliminating using multiplication first. All right, so here we see that we end up having to multiply both equations to either get rid of the x's or the y's. Okay, now we chose to get rid of the y's. To do that, we multiply the top equation by 2 because that'll give us a 12y. Multiply the bottom equation by a negative 3 because that would give us a negative 12y. Now, if we wanted to get rid of x's, we could also. 5 and 9. What two numbers can, or what one number can you think of where 5 and 9 would meet? That would be at 45. So I would multiply the top equation by 9. 9 times 5 is 45. And then the bottom equation by a negative 5. That would give me a negative 45. So here I have a positive 45x, and here I have a negative 45x. But notice if I did that, I'm working with awfully big numbers. That's why we're going to work with the y instead of the x's in this case. Sometimes x is easier, sometimes y is easier. In this case, y, we're working with smaller numbers. So once again, the top equation, we're going to multiply by 2. And the bottom equation, we're going to multiply by a negative 3. All right, let's go through it. 2 times 5x is 10x. 2 times 6y is a positive 12y. 2 times 2 is 4. Let's go to the bottom equation. A negative 3 times 9x is a negative 27x. A negative 3 times 4y is a negative 12y. And a negative 3 times 24 is a negative 72. Now we're going to add the new equations. We add going down. So if we add going down, 10x plus a negative 27x is a negative 17x. The 12y's will cancel out. One's positive, one's negative, so it's going to cancel out. 4 minus 72 is going to equal to a negative 68. I want to get this x by itself. I'm multiplying by 17, so I do the opposite of multiplication, which is division. So therefore, I'm going to divide both sides by a negative 17. So a negative 17 and negative 17. They cancel out, and I'm left with x is equal to 4. Now I go to my top equation, or to either one of the equations, but the top equation is the simplest, and I plug in that 4. So now I got 5 times 4 in place of that x, plus 6y is equal to 2. 5 times 4 is 20, plus 6y is equal to 2. Subtract 20 from each side. I end up with 6y is equal to a negative 18. Divide both sides by 6, so divide